Mic is not on. OK, now it's on. I hope you can hear me right in the back. We also have a bit of a echo problem, characteristics of large rooms. I'll try to talk slowly. Might put you to sleep, but you'll sleep happy, at least. So welcome to this session on System Center. I just want to give a brief context before we dive into what's coming up in System Center. As you all know, the IT operations is undergoing a transformation as more of the on-prem infrastructure and workloads move to the cloud. Our own management story is undergoing a transformation. I just would like to see a show of hands on how many were there in today's session by Jeremy Winter on Azure Security and Management. Did anybody attend that session? OK, good. A few people. The crux of the matter is that we are developing a number of capabilities, management capabilities in Azure under the umbrella of Azure Security and Management. And the question for us in this room is, what is, in all this, what is the role of System Center? What are we investing in System Center? And what's the direction for System Center going forward? Right? I'll try to cover all this in this session. First, a quick recap of System Center 2016. 2016 was all about two things, actually. One was software-defined data center. The other one was improving the fundamentals. Windows Server 2016 was a major release which completely revamped software-defined networking, storage, and compute. VMM 2016, and to some extent, Operations Manager 2016 were about supporting SDDC. Of course, we didn't complete the job, and we are continuing to make that support more full. But that was one of the prime goal in SE 2016. The other area was improving the fundamentals across SE components. For instance, improving the performance and the self-service portal in Service Manager, PowerShell improvements in automation, and improvements in DPM, particularly the modern data backup storage. In this time frame, Config Manager also went into a thrice-yearly cadence to better support Windows clients, and all this happened in the 2016 time frame. But even as we were executing on 2016, the landscape in front of us was changing. More stuff was moving to the cloud, and Azure IaaS was seeing phenomenal growth. Today, and of course, you can get more on 2016 in a session that's coming up on Thursday. Today, hybrid is the reality. More than 2/3 of the organizations are already in the hybrid mode, according to this survey. And our own survey indicates that an overwhelming majority of customers think that hybrid is a viable long-term strategy. Here is another interesting data point. If you look at how the cloud VM install base is growing compared to on-prem, it's clear that a lot of deployments are happening in the cloud, and also stuff is moving from on-prem to cloud. For us in Microsoft, this kind of poses us with two tasks. One, to make sure that those customers moving to the cloud, either migrating or expanding their footprint already in the cloud, particularly, we are talking only about Azure here, face no friction in doing so. And that's the goal of Azure Security and Management, to provide enterprise-grade management services in Azure. The second part of that is, for the customers who are on-prem, we would like to make sure their needs are also met. And that's where System Center has been focusing. And of course, we would like to do all the improvements that System Center needs for the customers to continue using System Center. So far, the Azure Security and Management has provided complementary set of functions that are available to System Center users. Going forward, we would like to make sure that the attach between System Center and Azure Management and Security is easier, and the advanced capabilities that are mushrooming in the cloud, if I may use the word, are available to System Center customers. Now, if you look at the areas that System Center handles, I have divided into 3 broad categories here: provision, configure, automation, and then monitor, analyze, and remediate, and the last one is protect and secure. These correspond roughly to many of the functions that Azure Security and Management provides today. And these are a whole bunch of functions. Some of them are complementary. Some of them provide functions that System Center don't even has. So instead of looking at the whole list, let's look at SCOM as a particular example. SCOM provides continuous health and performance monitoring on-prem. It also has a good alerting story, and it provides reporting and data warehousing. A set of services in OMS that complements SCOM today are log analytics, which provides deep insights based on logs collected from SCOM or any other third party and provides the correlation across all these sources so you can get a big picture view. You have Service Map, which provides the dependencies between your servers and ultimately applications, so you can use it for any number of reasons to basically get deeper insights into what's going on with regard to your health and performance on-prem. I'll actually show a demo on that. And then we are developing a new alerts management capability in Azure Management that will provide a bunch of intelligent correlation and alert management, along with situation management and root causing and troubleshooting. None of these capabilities actually exist in SCOM today, but SCOM can potentially hook up to. We also have capabilities like Network Performance Monitor and App Insights, which sort of fill the gaps that SCOM has in these areas. We haven't so far provided the attach that is seamless and highly usable to these services, but that's one of the goals. So the reason for talking about this is that when we look at System Center, we got to realize that we will have certain capabilities that are going to be natively available in System Center as we go forward and develop those and address those improvements. At the same time, we'll continue developing advanced capabilities in the cloud, in the Azure Security and Management umbrella, that will be available to System Center on-prem customers. So the last of this is Workload Insights, a service that we are developing that provides SCOM-like monitoring for Azure IaaS workloads. So essentially, if you are a customer who is intending to move your stuff from on-prem to the cloud, you can get the same level of monitoring that SCOM provides using that service. One can also imagine at some point in time, the same service can also attend to on-prem monitoring, hooking up on-prem workloads directly to the cloud, but that is a little far away. So looking ahead, what we are intending to do, our objectives are, 1, to keep improving System Center experiences. And we are going to do this at a much faster cadence than we have done so far. We are going into this semi-annual channel release mode, which is basically a 6-month release of System Center with a smaller payload, which will address some of the more immediate priorities for customers and continue doing that every 6 months. We are no longer in the business of a 3-year release cycle. But this also means that we are able to react in an agile manner to developments as they occur. I mean, things are in a great deal of flux right now in terms of the developments that are happening in the cloud, the manner in which customers are migrating to the cloud and so forth. And what we focus on in System Center will reflect that in terms of our own priorities. And having a shorter release cycle makes it possible for us to react quickly and address the top problems in a short cycle. At the same time, we'll continue to enhance Azure Security and Management so that the enterprise-grade capabilities are available to customers who move to the cloud, as well as they are accrued to customers on-prem. So this includes improvements in log analytics, which is already happening with the migration to the Custo system, Workload Insight service I mentioned, alerts management, Azure automation improvements, new governance initiatives, ITSM integration, which we'll show here, and Azure backup and so forth. In every area that you can imagine, there will be new services that will be developed and be available in the cloud. And we would like to make sure that wherever it's appropriate, those same services are available to be utilized by System Center customers for on-prem management. And finally, having done all this, we want to make the attach to Azure and the migration easy as well. And that and those are the broad contours of what we are attempting to do going forward. Now let's talk about the System Center semi-annual channel itself. The broad focus areas are, one, to continue to support Windows Server. As you may know, Windows Server is also on a half-yearly cadence going forward. And it's the same principle that we are seeing in the System Center area that Windows Server is also seeing. To be able to adjust to the dynamic realities of the server, they're also going in that direction. And System Center will continue to support Windows Server in that journey. We will address a whole bunch of improvements in fundamentals wherever they are needed. And these relate to the top customer and partner asks. And we have a backlog-based model that we will use in the 6-monthly cadence to have a list of things that across System Center components, whatever bubbles up to the top, we'll take up and address in the 6-monthly cadence. And then finally, the goal, which is actually a long-term goal, is to make sure that System Center is attached to Azure Management and Security, and advanced capabilities are available to System Center customers. So the release cadence for System Center in the immediate future looks like this. On November 8th, we will have the System Center 1801 previewed. 1801 refers to 2018 January, basically. And that's when the first semi-annual release of System Center happens. And then after that, there will be another release in the second half of 2018, which we're calling 1800X. And in every one of these releases, there will be a preview that precedes it by a few months, 2 to 3 months, so that customers can kick the tires, see how it is, and then we also get a sense of the stability of the release before we actually go GA. And the planning for these releases, which is very important to understand, that the planning will be also on a semester cadence. We will only look at what is the next 6-month plan. We don't have a grand plan of, hey, let's plan for 5 years and take the 6 months or the first 5 years. Every 6 months we'll plan, and then we will execute in the next 6 months. And these releases will be aligned with Windows Server releases. And importantly, the access to the semi-annual channel will require an active software assurance license. Please remember that in this process, System Center 2016 will continue to be supported for the 10 years, like any other System Center long-term servicing branch release. And also, in this cycle, the last bullet shows long-term servicing channel, which means some snapshot of the release will be taken as a stable release for the next 2 or 3 years, where it will be supported for a long time. So if customers can opt to go with the 6-month cadence or can pick up the long-term servicing channel releases at a longer cadence, choice is up to the customer. Now, Config Manager, which is basically client-focused, is going to operate at the current thrice-yearly cadence to better support Intune, the client, and the client CBB. So at every 6-monthly cadence of the rest of System Center, there will be a current release of Config Manager. But right now, we're not aligned at the semesterly cadence between Config Manager and the rest of System Center. That's one of the things we are looking into to see better alignment. But right now, Config Manager feels that the customer is best served by coming out thrice a year with the client releases. And let's look at what's in the semi-annual channel release 1801, the first release that's coming up. The coverage, as I said, is based on the set of top asks or top priorities in every 6 months, and this is the 6-month picture for 1801. It doesn't generalize to the next 6 months or beyond that, but in the first release, the feature focus is on the top 4, OM, VMM, Config Manager, and DPM. All of these System Center components will get the latest security and other fixes and will be released with that. And we are also going to provide Azure attached features for all of them. So this picture is basically, as I said, again, reiterating, this is just the 1801 picture. The next picture could be different for the next release in terms of the priorities. The investment areas are broadly in 3 categories. One is enhanced heterogeneity support, which is enhanced support for Windows Server, Linux, and VMware support in DPM. A focus on fundamentals with improved user experience, performance, reliability, and efficiency. And finally, better with Azure, an SE attached story for pretty much all the components attaching to the services in Azure Security and Management. Now, the features are selected based on what customers ask us in the user voice and in our own interactions, and what we think are areas where System Center needs urgent improvements. So we'll go through each of the areas and just do a run-through of the kind of features that are coming up and show some demos also. I just want to first take Config Manager out of the table here, because we are not going to spend a whole lot of time in this talk on Config Manager. Config Manager, as you know, is focused a lot on client, not so much on the server side. But the notable investments for Data Center on Config Manager in the most recent current branch release, which is called 1706, which was June of 2017, where here, as shown here, notably in-place upgrade for Server 2016 and data warehousing and support for Azure IaaS. Coming up post 1706, they're going to support high availability for their servers on-site, Pixie network boot, and server groups with cluster patching. Of course, this is a sparse list, but you will see in general, the list is sparse across all the components because these are all 4-month or 6-month lists. I'd recommend that people attend the session on System Center Config Manager for a broader overview and roadmap. That's coming tomorrow, same place here at 4 o'clock. Now let's go to the other components. Starting with Operations Manager, I'm going to go through some highlights that are coming up. The first is HTML5 Web Console. We all know the current console based on Silverlight has its own limitations. The new HTML5 console first will support multiple browsers, including Edge, Firefox, and Chrome. We'll have improved performance and UI. I'm going to show a demo, but you might not believe the second bullet looking at the demo. I've been having problems all day in connecting to the remote server. But that's something that HTML5 will bring. We have native widgets that provide ready-made capabilities that customers can configure and display in the widgets, along with the ability to customize and extend these widgets. And finally, you have diagnostics, debugging, and drill down all in one place when you look at the HTML5 dashboard. So I'll just go to the demo and show what exactly it looks like. Right. So this picture is a dashboard that the administrator is configuring for monitoring SCOM management group. As I said, there are 7 widgets. Let me just quickly show you what those 7 widgets are, and then we can walk through them. If you look at it, these are named Alert, a state widget, Performance, Topology, PowerShell, Tile, and the ability to create a custom widget. Those are the names. The first one you see here is the Topology widget. It's a very simple imposition of state over any image the user chooses. Let's look at that. You can choose a SCOM group or object. In this case, multiple objects are selected. For the display, you can choose a diagram on which the state can be imposed, and then it shows how often the state should be refreshed and the name. Right? And the next widget is the Tile widget, which shows both the alerts as well as the state. Here it shows, basically the second diagram shows everything green. It shows availability, performance, configuration, and security all in one place. And you can choose what exactly the objects and groups you're trying to look at. These set of graphs consist of the performance widgets. The performance widgets allow you to look at time series view of metrics for SCOM groups or objects. In this case, we have chosen all the operations manager objects, which is all the stuff that's being monitored in this demo. There are about 6 of them that you'll see here. The metric chosen here is the health service agent utilization, how much processor the health service agent itself is consuming. And the criteria here shows the time range. We are looking at the past 7 days. And the display shows the target, which is the monitored object, the full FQDN path and the last value of the object, and the completion is same as before, which is the refresh interval. So if you look at this, this is basically showing a time series view of the objects that are being monitored. Likewise here, this is a state widget which shows the health state of the monitored objects. And here is the alert widget, which shows all the alerts pertaining to the monitored group or objects. An SLO widget shows availability, performance, configuration, or security-related parameter and how much it's satisfying the pre-configured notion of a target availability, red or green. And again, here is a topology widget which shows the state of various agents being monitored. These widgets are customizable. I'll just show you the custom widgets, which are basically a way you are monitoring with custom rendering that you can take from third-party sources like HighChart and incorporate in your widget. Let's look at how that works. You're essentially writing HTML source code that looks at what data you want to get from SCOM and what rendering you want to do and how you want to show this, right? And you can have very sophisticated rendering based on the customizations you put in there. And finally, you get a complete drill down experience. Let's go to the alerts, right? And if you choose one of these alerts, you can get a complete description, you can get history, context, rule properties, and so forth, all in one place that you can manage. This capability was not available before. And you can rearrange these things in whichever way you want by editing the dashboard and moving things around. That I'm not going to show here, it'll take some time. So essentially, you now have the ability to create dashboards for your operators. The administrator has the ability to create dashboards for the operators in a way that is much simpler than before and gives much more information in a rich format. This clearly doesn't replace some of the work that our partners like Squared Up do to produce much richer reports for the consumption of higher-ups in the organization like CIOs and other personas. But this is a great improvement over what we had before in Silverlight. And this was a key ask from customers. Let's go back to the presentation. The next thing is log file monitoring. Just a second. We had Linux log file monitoring in SCOM. And just like the Silverlight dashboard, it has its own limitations. You have limitations in terms of choosing the log file and how much scripting you have to do to actually get to useful information. The new implementation is based on the Fluentd stack, which provides the ability to use plugins and customize it and extend the log file monitoring you can do. The agent here for log file monitoring is common with the agent that Azure Security and Management uses, which is the MMA Linux agent, which can do both monitoring for SCOM as well as monitoring for analytics and send the data to the cloud. What happens here is the Fluentd stack has, essentially, if you're not familiar, has 3 different plugins: the input plugin, the filter plugin, and the output plugin. The input plugin allows the Fluentd stack to be used with multiple different sources that SCOM is monitoring. The filter plugin, which has all the intelligence to basically take the information that is being monitored and then process it in a way that you want, and then send the output as an event, which goes through the output plugin to a SCOM web service, which then eventually gets published in the event channel, and then the SCOM MP picks it up for alerting or dashboarding or whatever else you might have. We have pretty much all the versions of Linux are supported for log file monitoring. And this is quite a chart, but we're not going to go through this, but it just shows the kind of filters that you can use in the SCOM plugin. They include various kinds of matching and filtering based on time windows that can pull out the information that you want, which previously you would have to write very complicated scripts for this. So these are provided out of the box by SCOM, and then you can also add other third-party or open source plugins to do the kind of log file monitoring that you would want on Linux. So this actually brings up the Linux monitoring capabilities of SCOM to a level that is far higher than what we had in 2016. The third highlight is MP updates and recommendations. What 2016 has is the ability for SCOM to first discover the workloads that are present, and then figure out if those workloads are being monitored, the MPs are present, the management packs are present or not, and then also tell if there are dependent management packs which are absent. So you can automatically figure out if your monitoring is complete for all the systems you have. So far, this has been available only for first-party Microsoft workloads, covering about 80 of them. Going forward, we are making this available for third-party MPs also, targeting about 56 partners with certified management packs. The diagram here shows how the MPs are published through Microsoft DLC, and then it's made available to SCOM. SCOM goes and pulls it up. If it is a first-party MP, it's a very smooth process of automatically discovering and installing it. For third-party, it's equally smooth, but there are some limitations. I'll just show you a demo of how this works. Okay, so this is a familiar screen if you had used update and recommendation in 2016. Sorry? Oh, thank you. I don't know why it's showing this. Sorry. The switch is lit up, but I'm not able to change it. Okay, let's change it to something else. No. Need help here. It's connected to SDI, but not changing. Trying a reboot here. Just a second. That's exactly what we're doing. The trusted solution, right? 3 times. I think the session will end before then. It's coming up. Sorry? Okay, something is coming there. Yeah, great. Well, okay. So, okay, if you're familiar with 2016 updates and recommendations, this is the screen that you would see, which basically shows the MPs after discovery, the MPs that are not installed or partially installed. What you're noticing here now is you have third-party MPs. A bunch of them are shown here from Infront and NICE and all that. If you are using a first-party MP and if it is not installed, the actions you get are get MP, and the get MP would actually fetch the MP and install it for you, and you're done. Out here for third-party MPs, let's look at Infront McAfee. If you get MP, It is just going to go to the partner's website where you have to manually go and download. The reason for this is our partners actually want to have some notion of control over, who's downloading and, basically maintaining that customer connect. So it's actually a process. In this particular case, Infront requires you to, McAfee requires you to basically, this vendor requires you to basically fill up the form and then download the MP. But once downloaded, let's go back to this. That's what I meant on the, right. Okay, very slow. Manager, no, where I left it. A second. It's not responding. Okay, anyway, once you download it, you would just use the same process to import MPs as you would with any other MPs. So the main thing here is not so much the process of installing the MP automatically, which works fine for first party, but the actual process of discovering that now works for all the third-party workloads that you're running. Now we can tell the third-party workloads are automatically discovered, and then the MPs are present, and if not, we can actually tell you to download and install. Let's go back to the presentation. Now, this part is what I was referring to as Azure Attached before, which is service map integration. How many are familiar with service map in this room? Good, a few. So service map is an Azure service, which was basically used to be a product from Blue Stripe, which Microsoft acquired, and now runs as a service in Azure Security and Management, which allows you to figure out dependencies between your servers, which server is talking to which other server, so that you can utilize that information in terms of troubleshooting and diagnostics in terms of dependencies. And ultimately, service map would also provide application dependencies, which components of applications are located where and where they are communicating. SCOM can now import the service map information from the Azure service and impose the health state information for related servers, so that you can try to figure out the health state of one, how does it impact the health state of other servers. This information, if you were to do it in SCOM manually, it's quite a bit of an effort. Service map, actually what it does is also keeps the information up to date. If you add new servers, if there's new pattern of communication, it automatically captures that. I'm going to again try to switch this, and I hope that it doesn't crash like before. Oh, it did my switch. Great. So let me first show service map and what it looks like. Here is a service map which is already configured for my workspace in Azure Management and Security. I'm actually accessing the Azure portal here. Let me show what service map actually shows for a particular machine. So you can actually add a bunch of machines or create machine groups in service map. In this case, there are these set of machines that are added to service map. And the service map agent, these are all, most of them are on-prem. They can be on-prem, they can be in the cloud, but the OMS or Azure Management agent must be running to be able to get that information. So in this case, many of them are on-prem, and then service map is actually getting the information from the agent. And if you look at a particular machine like ADM demo, MySQL, this particular machine, service map shows both the incoming and outgoing connections that this machine has. You can also group machines, like I said, and if you look at this group, it shows all the communication that happens between machines in that group. So essentially, it shows you a graph of dependencies, and we can filter it to see only the group-connected processes. And it shows, these are the set of machines that are communicating in this manner in this group. Now let's go and look at what SCOM shows. So this is a SCOM console, which basically has imported the information. This is a new MP that runs in the SCOM management server that imports this information from service map. And this shows pretty much the same topology of connections. These are Acme Web 0 and Acme Web 1 or I mean 000 and 002 are the front-end servers, which are connected to an app server, which is connected to the SQL, and there are these other machines. If you notice here, not all these machines may have SCOM agent running. So SCOM is not able to tell the health state. It just shows a blank here because it has no idea. And it also tells you that if you really are interested in this group of machines, that's why you install service map in the first place, the agent there, you might also want to turn on SCOM monitoring for these machines. And it shows a status superimposed on this dependency graph that it gets from service map. So it's a powerful tool to basically be able to see how the health state of machines are related to each other and what is impacting another. And the other thing is you can also see the individual machines here, just like you're seeing in service map. The SQL machine is here. And hopefully it will show the same kind of configuration that you see in the MySQL view in service map. Like I said, the interesting thing here is that if this topology changes, if new machines are introduced or whatever, it gets automatically updated in SCOM. So this is one case of tie-up. And the way you would actually configure this is also pretty straightforward. I was talking about Azure Attach before. The key to Azure Attach is to be able to do this fast and easy, as opposed to making it a laborious process. So if you go to SCOM administration, you'll see that this workspace is already attached. But, I don't want to run through the whole thing, but I'll just show you exactly what it takes to attach a SCOM to a workspace that's running in Azure. Slow. I'm running into an issue here in terms of that. The machine is freezing. Okay, yeah. So you just give the credentials, supply the password. You just have to specify the Azure subscription. And then under that subscription, it shows the available workspaces and resource groups. Right now, it's already selected. You would actually select it from a drop-down. In this case, there are only 2 of them. And then you will select machine groups that are already there in service map. You can add or remove. You can also select individual machines that are configured with service map. And you'll select which management server pool that communicates with Azure, and you'll complete. So it is as simple as going to the SCOM administrator console and connecting, establishing this connection with service map. And you can imagine that a similar construct exists for other services that I showed, whether it's alerts, whether it's network performance monitoring or App Insight or any of that stuff. The same template we would like to see apply, that you can connect to these services. Either you import information into SCOM or you export it from SCOM and provide a seamless experience for users to basically get those capabilities that are available in Azure management and security. So this is just one instance of what you could do. Go back to the presentation again. This we showed. So in summary, those were the highlights. This is a list of everything that is coming out in 1801 in SCOM, which includes log file I showed, setup improvements for Linux agents, Linux Kerberos support, and the improvements to Linux MPs. And on the fundamental side, an important thing that we're doing is also Visual Studio authoring environment for VS 2017, and that'll be available soon. And then I showed the service map integration that comes with Azure Attach for SCOM. So that's the net set of things we're doing for SCOM. And going forward, we'll continue adding to this list in a 6-monthly cadence, as I mentioned. Now, Vijay will talk about Data Protection Manager and what's coming up in 1801.
Thank you, Bala.
Yeah.
Thank you, folks, and welcome to the presentation on System Center. Can you hear me okay? Cool. All right. Thank you. As Bala mentioned, the entire System Center, including DPM, the primary focus has been on 3 pivots. One is to align with the Windows Server 2016 and provide a wide variety of workload support for backup. Second is on fundamentals. And the third one is having a great story for attaching to Azure. So through this presentation for DPM, we'll see the same theme repeat itself, and we'll use a few demonstration and props to kind of show you how that story pans out for DPM as well. First of all, DPM 2016, we are actually, as Bala was mentioning, in DPM 2016, we have added the support for several workloads, including SharePoint 2016, SQL 2016, as well as some of the traditional workloads like Exchange and Hyper-V. With the release of Windows Server 2016, we have made it really very compelling for customers who are relying on Hyper-V backup to leverage System Center DPM 2016. The reason I say that is because it has become very important to make sure your backups are reliable when you back up your Hyper-V virtual machines. With the previous releases of DPM and Hyper-V before 2016, you had the problem where you had to deal with consistency checks very often. That was happening because the DPM filter or the change tracking layer for DPM was running in the storage node, and if there are any outages for the storage node, this was causing the DPM to go into a consistency check mode. But with 2016, with the Hyper-V enhancements, we moved the change tracking layer from the storage node to the Hyper-V node. And on the Hyper-V, we are using the resilient change tracking so that even if your storage node went down or your Hyper-V node, the compute node went down, your backups are not going into a consistency check mode, and your backups are going to be much more reliable and have a SLA of 24/7. So that's a very critical piece for customers and IT administrators who want a reliable backup in their infrastructure. The other key thing that we added as part of the overall System Center Connect, which has been there for a while, but we've continued to enhance, is the Azure attach, right? We'll talk about some of the capabilities that I'll be lighting up in DPM as well as in Azure Backup and how that whole thing integrates together. And last but not least, we've added the support of VMware to be able, we can now back up VMware using System Center DPM 2016. And it's a very simple to use agentless backup which uses the native VMDK, the change tracking without installing any agents on the ESX host, and be able to back up and get the exact same consistent experience just like how you would back up a Hyper-V virtual machine. The other key capability we talked about was fundamentals, right? In terms of fundamentals, one of the key complaints that we've heard from customers is the ability to have a very efficient storage architecture for DPM. In the past, before DPM 2016, we had we used to we had something called raw storage, like we used the raw storage that the Windows would provide. And we did not have the flexibility to expand the storage depending on the dynamic needs of the workloads, right? So you had to either over-provision your storage or you had to keep expanding your storage, and there was no way to reclaim the storage back. So that was a significant problem because customers had to buy more storage than they really needed. With the modern backup storage, we're able to address that, and not only that, with the release of the current, the 1801 release that Bala was talking about, we're actually going to put the VMware capability along with the modern storage and ship that out to the customers. So why does that matter to you, right? I talked about inefficiencies in storage, and let me just show you how the modern storage helps you to leverage, very efficient and seamless backup story. First of all, we leverage the REFS storage stack in Windows Server to do your backups. What that does is essentially creates a chunk store, which is essentially a VHD of the the primary storage. It's a replica of the primary storage that we create on the REFS volume. And whenever there's a change that is made to the production workload, when some blocks are changed, maybe 5% of your data churned or 20% of your data churned, we take those data blocks and then replicate them to the backup storage. And when we do that replication, it's nothing but creating a REFS clone of your primary storage, right? That way, your storage requirement is actually just what you changed, and no more or no less. And given that it's based on the REFS clone technology, we're using allocate on write instead of copy on write. And what does that do to you? You can actually get much higher IOPS in terms of your storage stack without having to buy gobbles of storage and try to over provision and then have a slower backup performance. So you can get 3 times faster backups. And the most important thing just that comes out of maybe as a byproduct is that it's now workload aware. So if you have workloads like SQL or Hyper-V or VMware, you can actually allocate them into different storage stacks without having to buy multiple monolithic storage stacks. So you can just sort of make them more specific to your workloads, and you can give more or less IOPS depending on the requirement of your workload. Okay, so the next thing I want to show you is how do we leverage the Azure backup to connect to DPM to give you an instant recovery capability. Let me show you that with a demo and then just walk you through how this works. This number 6. Okay, there you go. Sorry. So here I have a DPM server which I've been backing up, and I have the E volume on my DPM on my production server that's backed up by DPM, and the same volume is also replicated to the cloud, and I have my cloud backups stored in my Azure Backup Vault. And here I have a recovery tool that we built, which can point to the backup vault, right, natively in the Windows Server. I can point out which DPM server I want to recover the data to. It's going to fetch all the volumes that are backed up to that backup vault and show me those, and then I pick the volume that I want to restore. It's fetching all the recovery points, so you may have backed up for several years. Now it's going to enumerate through all the recovery points that are there in the backup vault. I'm just going to pick the one on the 15th, and I'm just going to mount. So what this does is it takes it creates an iSCSI sort of protocol between the service and the client. And why that is important is because in the past, the entire orchestration of recovery from the cloud was done from the DPM console, right? So the DPM console, it used to construct what are the bits that have been sent to the cloud, what are the indexes of all the files that have been backed up, and all of that information is on the DPM server, and it's trying to search and find out the files that are being, that it needs to restore. In the case of the iSCSI-based recovery experience, what we've done is create an iSCSI target on the Azure Backup Service, and now we've exposed a volume of that iSCSI target to the client that we can actually browse and restore. So you don't need to bring down all the files and the indexes before you can start restoring. You can browse and restore the data that you want. So here I can just click Browse, and at this point I've not even downloaded a single bit of data from the cloud. I can just browse, see what data is there. Let's say I've been attacked by ransomware, I have some corruption. I can browse through what data is on the cloud before I do the restore. So here I have some files on my cloud volume. I can maybe pick the videos that I have. I can play the video directly from the the cloud volume, or I can just copy these files back from the cloud volume to my laptop right here. And play that, 1 sec. So I could just copy that here. And then start playing that. So it's very, very easy to do this. So I'm just going to replace the file that I have. So in just a few minutes, I can actually browse my entire backup volume in the cloud, and I can just bring down what files I need without downloading the entire volume. So this is very powerful for me. And all of this is possible because, let me switch back to the presentation. So all of this is possible because, like I said, we have an iSCSI target that we have created in the cloud, and we are using the same technology for whether you're backing up data from DPM to Azure, or if you're backing up Azure IaaS VMs in the cloud, or if you have Azure files that you're backing up using the native Azure Files backup technology. We have the same sort of interface to browse and pick your files that you want to restore and bring them down to DPM, or whether you want to pipe that to a server inside Azure. Use the same technology. And what the benefit of that is, obviously it just does it much faster, so you're not bringing down the entire data. So in case of the older sort of way of doing restore, we have to wait for the first byte to come down, because we need to enumerate what files have to be brought down, and then you do that. In this case, you just bring down just the files that you need, so your the time to first byte has significantly improved with the DPM connecting to Azure Backup. Okay. So the next important question, as Bala was also talking about, is very critical to make sure that you're able to monitor your infrastructure. And it's just not applicable just for your production workloads, but also for your backup infrastructure as well. Right? Some of the common questions that customers have are like, how do I know how much storage I'm consuming, both in Azure or on premises? Is my backup healthy? Not only that, can I see trends in my backup infrastructure over a period of time? Maybe a few weeks, maybe several months. I want to see how my storage is consumed. So what we've done is, in the past, what we had was the ability to take all the data from DPM, send it to a COM data warehouse, and then you would create these reports and then show it to your CTO. Instead, what we've done is taken the benefit of connecting to Azure, and now we can push all the data that we have in DPM to a central place in an Azure Vault, and from there we can create Power BI reports to show you all the information across your DPM infrastructure on premises. Let me show you how that works. Okay, I think it's not picking up. So I'll just skip that for a second. Let me just show you the there you go. So here you go. So these are the reports that we have in Azure. For instance, you can actually go there, take a look at your entire environment, whether you have your backups coming from Azure IaaS VM to the same vault, or whether you have data that is coming from your on-premises infrastructure to the Azure backup. You can see all of that information in one place using the Azure Backup reports. Okay. So again, like I said, you can take a look at the job status. You can look at the trend analysis of your backup SLA across a period of time, the list of jobs that have succeeded or failed, and how they're doing in terms of what are the top errors that you're seeing in your backup infrastructure, all of this is available to you in one place. And this is sort of how it works. So the data is now sent from your DPM infrastructure to the cloud using the Azure Backup Agent. And once the data is in the Azure Backup service, those data is actually then pushed down to Power BI, and you can use the Power BI to actually power all of this, the reports across your, infrastructure. The best part is you do not have to deploy any on-premises infrastructure to enable this reporting. The second part is it is pretty much free, because in the Power BI, I think you get like 5 gigs of space that you need for your, that you can store for free. So all of that data, if it's within 5 GB, it's actually, I think I may be wrong on the size, but yeah, it's plenty of space that you have in terms of, looking at the storing data and consuming it in Power BI. And the most important thing is it is customizable. So depending on what your CTO is looking for in terms of your report layout, if you wanted to drill down on certain aspects of your infrastructure, you can actually do that. And the last but not the least is it actually spans across your environment. So whether it is DPM running on premises, or you're running Windows Server on premises, or whether you're running IaaS VMs in the cloud that you want to back up, all of that data gets to one single place, and you can publish reports from right there. Just to reiterate, these are the 3 things I talked about. So one is expanding our footprint, make sure we have a great story for Windows Server 2016. Looked at the fundamentals, addressing the key pain point around storage, consumption, IOPS for the DPM customers. Last but not least, but have a great Azure attached story. And the 2 key things we're adding is one, instant restore capability, and second one is pushing the data to Azure Backup so that you can have centralized reports right there from the cloud. With that, I turn it on to Riaz.
Thanks, Vijay. So now we move on to Virtual Machine Manager. So a lot of this functionality, like Bala initially mentioned, is come through customer user voice. Some of them is through interaction with customers by us as well as the Windows Server group. So the set of features that you're seeing is stemming from that discussion. So the first one is nested virtualization, right, which is basically hosting a VM within a VM, right? You don't need a physical machine to host VMs. This functionality Windows Server added in Windows Server 2016, and now we are sort of enabling that in VMM, so you can orchestrate the nested virtualization feature. This is very useful, especially in DevOps, dev test scenario, or hands-on labs or demo scenarios where you could use nested VMs much easily. Like I said, it was added in Windows Server 2016, so there are some of the requirements, like you need base OS's 2016, as well as there has to be hardware capability for virtualization to support nested virtualization. One of the other features, VMM already supports VMware migration to Hyper-V. However, we only supported BIOS boot types till now, and with this now we support UEFI based firmware boot type for VMware VMs. They directly translate to Gen 2 Hyper-V VM. We do pick the right defaults, and it's actually much faster. So we made some fundamental improvements in migrating the VMware VMs, and that's making it 50% faster. So in Windows Server 2016, there was storage quality of service added as a feature. VMM also added the same support, but we added for storage spaces direct in VMM 2016. Now we have added support for SAN storage. We also allow setting the storage cost settings in your VM template. So when you instantiate a new VM using the VM template, by default you get that storage quality of service. But you do have an option to change it while you're instantiating a VM. Plus, we have added the abstraction to the VMM cloud abstraction as well. So now your tenants and self-service scenarios can also take advantage of the storage cost policy. How many of you have used Hyper-V Console Connect and have problems copy-paste? Okay, so this is one of the high user voice feedback that we got to say, hey, please support copy-paste for your Hyper-V Connect. And so now we are enabling enhanced console sessions in, for Hyper-V connection, for Hyper-V Connect. So you can do exactly copy-paste however, there are certain policies which are applied. So by default, the host may not have, or you may want to only restrict it. So that's why there's a toggle between basic and enhanced sessions. So it's an opt-in feature. So given that I've sort of gone through few of the features, let me go through a demo. To set the context of the demo, let's say there is a company who is developing a payroll application which involves user-sensitive data. The development team has created a demo VM and they've deployed it in their VMware environment. However, they want the sales team to take that demo and show it to their customer and actually even take customer data to sort of show the demo in that scenario. So each customer for the demo purposes would need to have their own VM, and the sales person for his comfort that the customer data may not leak, he has his own host. Given that we didn't have that much physical hardware, we would sort of leverage the nested virtualization feature of Hyper-V to create those many hosts. Okay, so I'm going to show you in VMM essentially some of these features. So first of all, VMM has some of the ESX host, VMware host in here, as well as the Hyper-V host. The dev team have already deployed the demo VM on the ESX host. Okay. We have also created we have taken some of the VMs and enabled nested virtualization on them. So you can see nested virtualization is enabled. And then we have added that nested VM as host right here. Okay. So now let's go convert the VMware VM . So this was the VM that the dev team had created as a demo. And we'll walk through the wizard. Oh, I need to, let me change the name of the VM. Demo gods are not with me. So anyway, I'll get the list of hosts, and one of the hosts that where we want to deploy is the nested virtualized host, which should show up as one of the available hosts for us to deploy. So here is our host. This is the nested host. And then we'll walk through the wizard. We don't need network connectivity for this. And we'll go convert it. So while the migration is happening, this will take some time. Let's look at one of the already migrated VM that we have. So let's connect to this VM via console. Okay, and here we have our payroll application. Like I said, when we are at the customer site, we want the customer payroll data for the demo. So we'll copy this customer file. And because this is running as a classic console connect, we can't paste here. So let's open this in enhanced session mode. We'll log in. And now we can paste that file here. So we sort of saw nested virtualization, enhanced console session, VMware migration, all as part of this demo. So let's move on to see other features. So shielded VMs. Windows 2016, Windows Server 2016, we added Windows shielded VM, and with the Windows Server 1709, Linux shielded VM support was added. Similarly, VMM has also enhanced to support and manage, so provision and manage Linux shielded VM. Windows Server 1708, actually all of these are new features in Windows Server 1709. The fallback HGS server setting configuration that they honor is also something that you can configure through VMM now. And with the SDN stack supporting encrypted networks for the tenant subnets, that also you can configure through VMM with our new release. Other SDN enhancements, and these are sort of features which already existed, and we're just enabling it for in this VMM, right? So you can configure software load balancer via the service template. Previously, we did have support for configuring the network, the hardware load balancers with service template, and now we are extending that for software load balancer as well. Given SDN stack is inspired by the Azure design of networking, the Azure mechanism of guest clustering is based on floating IP, and which is what SDN stack also now supports, guest clustering via floating IP. So VMM has enabled configuring floating IP through VMM. So one of the other pain points that we've been hearing from customers is there are multiple tools to manage their environment. You have to use VMM for some things, you have to use Hyper-V Manager, you have to use Failover Cluster Manager, and so on and so forth. And that list increases with Windows Server inbox tools. So Honolulu is sort of trying to solve that problem from Windows Server perspective and sort of consolidating and coming out one experience across all the tools. So we are exploring with them to see how we could integrate VMM with the Honolulu experience and sort of give a context-sensitive way of moving around. So let me show you a quick demo of what that scenario looks like. Okay. So from VMM, I can actually, launch Honolulu. Now let's say, you have a host in VMM and you are seeing some issues with that host. You want to sort of look at the event viewer for that host. You would end up, doing a remote desktop to that host. You would end up opening the MMC event viewer to look at the event logs, right? What if you could right click on the host and say troubleshoot and takes you straight to the event viewer for that host to go troubleshoot and see what's going on. Okay. So we've also heard feedback at times saying, VMM shows me some information about a VM, but it's not enough information about, the IOPS or the disk storage and things like that. Similarly, if you were able to connect and look at more information, which you are interested in, Honolulu has that information, then you could sort of directly click on the VM metrics and get to the VM details that you are interested in. So this is one of the explorations that we are doing. And similarly, if new functionality gets enhanced, like for example, even failover cluster manager, if there are features that are getting added, you could sort of leverage that from VMM through this sort of integration mechanism. So let's move on to the next. So better with Azure, attached to Azure. So one of the VMM already has an Azure add-in which allows you to manage Azure classic VMs from the VMM environment. And we heard a lot of feedback from, again, customers saying, it works for the public region, but we want it for more regions like China, US government, Germany. So we are enabling that. Also, there is a lot of requests for managing the ARM-based VMs from VMM through that add-in. So we have added the ARM-based managing. It's the same basic operation that is there for other advanced operations or other operations. You would still want to go to Azure and do those operations. However, the basic operations are available in VMM to do. And we have also added the support for Azure AD to connect. Previously, we only did certificate-based connection, authentication connection. Now we support Azure AD. So one other exploration that we did was how can we sort of leverage the log analytics. Log analytics has a lot of power, a lot of you could get interesting new data insights. So before I go to the slide, let me first go to the demo. Okay. So I understand that not everyone is a VMM users. So first let me just give a little bit of background. So when you do an operation in VMM, each operation ends up being a job that you execute at the back end. So these are all operations run as jobs, right? So the idea of this thing was that customers want to look at the job details. So if we use basically VMM PowerShell to pull the job details out from VMM and push that to Azure Log Analytics service, and then you can sort of do some insights on top of that. So here is an example of what sort of we did. So if you are interested in sort of knowing, hey, what jobs are failing, when did the jobs fail, in terms of time on a timeline wise, or which is the most failed job. So you can maybe even go look at saying, why is this job failing so often, and can I do something to sort of remediate and improve my, fix it. You can also look at, total jobs that were run in that environment. And the beauty of this is, especially with people who have multiple VMM instances, customers, that they could all get connected to the same workspace, and now you can look at across your VMM instances how your job data is, how the job failure and how the job details look like. You could also, if you want to look at saying, how much time each of these jobs are taking, what percentile, and you could sort of look at from that perspective, and maybe there are some places where you could do some fine tuning in your environment. So this is a solution that we created. It's available on Azure Quick Start templates. It's in Git, so customers can sort of take this, modify, contribute back, or get inspired and build other similar solutions which may make sense. Well, back to the slide. Looks like it's stuck again. Yeah, okay, cool. So what I showed was some of the things, right? But basically, one of the powers of log analytics is you could take multiple solutions, like, you could take your event log information and then use that to correlate with these job failures to say, is there some of those failures attributed to this job failure? Or you can make query-based alerts, right? Leverage Azure Automation. If you know that this particular failure means I need to fix it this way, you can use Azure Automation to sort of remediate your own solution. Oh, looks like I'm out of time. But so I'll quickly run through because there's still some more. Okay, so I showed some of the features, but I think there's a lot more features that are there, and this is the full list. Automation. So the orchestrator customers have been over the years giving us a lot of feedback around how we could improve orchestrator, and those are all valid feedback. However, when we looked at this few years back, what we realized is it's not very easy for us to just add those features in orchestrator. It almost requires us to redesign orchestrator, and that's what led to getting service management automation as that solution. As we got there, we got more feedback that, hey, now we are getting into the hybrid world. We need hybrid support. We need we love our orchestrator UI, graphical runbooks, and we need that, and so on and so forth. And that culminated into sort of getting Azure Automation as the next evolution of this story. And so I just wanted to sort of quickly go through some of the things which Azure Automation has now, and which, a lot of these have been sort of feedback from our System Center, automation customers. Rich graphical interface automation, runbook, now it's pretty much at par with what is there at SCO now. There is heterogeneous script support. So we also, besides PowerShell, now there is support for Python, there is Bash support, which is in preview. And one of the misconceptions that most folks have, at least from when I've been talking to customers, saying, oh, but Azure Automation is for resources in Azure, right? Which is true, it is for Azure, but it is also for on-premises. You can use Azure Automation to automate some of the things which is on-premises, right? There is RBAC support added, and multiple integration points. One of the other feedback was, event-based automation was another SCO customer ask. Source control integration was another one. So a lot of these have been addressed in Azure Automation. And then your question is, oh, that's great, but I have a lot of assets in Orchestrator. What do I do with that, right? And which is where the Orchestrator migration toolkit comes to your rescue. It allows, it has, we've migrated the Orchestrator activities into PowerShell modules. We have taken the integration packs that we have shipped and converted them into PowerShell modules. If you have your own custom IP, which are built on top of the Orchestrator SDK, you can even migrate those using the Orchestrator migration tool. And then run the migration tool, which will give you the Azure Automation runbook that then you can use it, import it into Azure. I do have a demo, but looks like given short of time, I'm going to skip the demo and move to the, we have beta available, and we encourage you to sort of go download from the download site. The older version was beta it's being refreshed right now, and if you have feedback, please provide feedback at the Azure Automation user voice. We have a migration toolkit tag. So I'll skip the demo. ITSM integration. So a lot of customers are now in the hybrid model, and they have their on-prem ITSM solutions. However, they need to sort of even deal with some of the resources in Azure. So ITSM's connector solution has multiple aspects to it. One, it connects your on-prem ITSM solution like Service Manager to Azure Log Analytics. It also allows you to create Service Manager tickets or the tickets from incidents from Azure onto your on-prem Service Manager. Given that you could have multiple solutions in Azure Log Analytics Service, now you could use correlation to help troubleshoot some of your problems. This ITSM solution is in public preview. It is available for Service Manager, for ServiceNow, for Provence, for Cherwell, for all of the different, for these 4 ITSM solutions. I do have a demo. I don't know if you, okay. However, the demo had a part 2 demo, which was sort of, we had a small demo here, and then we wanted to extend that demo into the next session, which is on Thursday. We are giving for Best of System Center 2016. So maybe we'll do the big demo there. So you guys come there. Thank you.